Okay. So thank you so much, OMH, for having us today. Today we'll be speaking about learning car hacking through test benches. Okay. Today we'll be covering a various amount of content. So I'll be covering the journey of bench two, and then Emma will be covering building challenges and getting into the infotainment system. And then Pacey will be covering features versus vulnerabilities and summary of our learnings. So a quick introduction again to who are we. Hi again, I'm Alina. So sorry about that, about all the feedback. So I was getting a bit of delayed audio. But basically, I have my core team over here. You see Pacey and Edmund. And unfortunately, Javier is sick. We asked him not to join this time round, but he will join us in future conferences. And then my interest is, of course, car racing, pen testing, OT, and automotive systems. And Pacey has been with us since the start of 2019. So she's interested in digital forensics, incident response, and hardware hacking. So if you're interested, you can talk to her more about it. And then for Edmund, his interest is also on hardware hacking and pen testing automotive systems. Yeah. So together, CSQ, we are actually from Singapore. So we have a total number of members of 20 plus members, and we are part of the wider cybersecurity community group here in Singapore called Division Zero, as mentioned earlier in the start. And we also power the Automotive Security Research Group, the Singapore chapter. So ASRG is also the main quarter is based in Stuttgart. So we actually open up the Singapore chapter here to actually engage with more audiences. Okay, so basically, what are the goals of CSQ? So CSQ is a non-profit quarter. It's like a community group that actually facilitates and promotes cybersecurity awareness to the community in Singapore. So we are trying to go international as of now also. And then we also want to empower like-minded security enthusiasts in gaining hands-on experiences. And ultimately, we want to contribute to the automotive security industry through ground-up research, community engagement, and building of test benches. Okay, so now I will proceed to talk a little bit more about the journey of bench two. Okay, so previously for bench one, we actually mentioned that we will actually feature a connected vehicle in bench two. So a quick recap is that this is our roadmap. So we are actually we plan for prototype two, which is bench two. It will feature connected vehicle functionality ranging from SAE level 1 to 2. So that will actually feature some of the advanced driver assistance systems and adaptive cruise control. And then in addition, eventually we want to be able to work on autonomous vehicles and contribute to the safety regulations of the autonomous vehicle industry. Yeah, so we are kind of like about 2 years and 2 months in right now for CSQ. Okay, so as you guys may be curious and never seen bench one before, bench one is the picture on the left. So that's another member. He's holding up an immobilizer, and picture on the right is bench two. As you can see, it's a little bit more organized. So when we first started out, we just wanted to make things work. So we don't know where to start, and we just went to like scrap yards and eBay to actually purchase our items. And we actually nailed it on a simple piece of plank board. Yeah, just to showcase. Yeah, so we have the screen, Raspberry Pi, and all over there to just control. And then we actually allow like some of the members to sort of SSH into the Pi, about like 2 to 3 members at one go, so that we can all interact with the bench itself. So for bench two, we also did the same thing, but we actually added like the infotainment systems and all, which we'll go through a little bit more later. But let me just go a little bit quick recap on what did we do for bench one purchase. So those who may be interested to set up your own test bench, this is a quick one that you can do under like 500 Sing dollars. So you have your wires and connectors and power supply unit that is definitely necessary to actually purchase. And then you have your instrument clusters, you need to purchase them because you conduct spoofing and replay attacks. And then you have your electronic control units, your ECU, which actually allows connection towards the instrument clusters and parameter control. And finally, we have the ignition key cylinder immobilizer, which provides the starter ignition signal for the ECU. So as for analysis tools itself, we definitely recommend like buying like a CAN to USB translation device. So like the Cannable and Cannable Pro, which provides communication between USB to CAN, and also a CAN transceiver if necessary. It actually provides like differential transmit capability to send and receive from the controller. Okay, so that's a quick recap about bench one. Okay, so moving on to bench two, so where we actually got the inspiration to do bench two. So bench two was actually hugely inspired by Kin Labs, their CDE findings, which was actually announced in Black Hat US 2019. So since there was already a known funding, we wanted to utilize that to actually allow us to understand different vehicle protocols and infotainment systems. So as opposed to bench one, so bench one itself, we were just mainly working on CAN bus. But for bench two, we were working for more than just traditional CAN bus. So there are actually different protocols for us to understand and work on, such as the MOST and Ethernet protocol. So the MOST protocol is usually used for infotainment systems, and automotive Ethernet is used for mainly vehicles that are more common or more modern these days. And then as you can see that there's an image in the middle. So that actually simulates how we actually build our test bench. So one of the most important things is the central gateway module. So it actually contains all the different vehicle protocols over there, like the FlexRay bus, which is actually used for brakes because it's a high-speed bus. And then you have your lane bus, which is used for like your keyless entry systems and all. And then you have various sorts of different CAN bus, PT CAN, K CAN, and chassis CAN, which I will be talking more about it later. Okay. So, just like I mentioned, like, there's a different protocols within the vehicle central gateway system. So you have your MOST protocol, your FlexRay, your LIN bus, CAN bus, and automotive Ethernet. There are also different variations of CAN bus. So, what does it really do is like the PT CAN is a short form for powertrain CAN bus. It actually controls all the units and modules associated with the powertrain itself. Then we have the chassis CAN. So the chassis CAN actually controls the modules, sensors, and actuators commonly used for power steering for our current vehicle that we were testing on. And for the KCAN, so KCAN is not a common terminology out for other vehicles. So each vehicle manufacturer have their own naming convention for CAN bus. So in this case, for the vehicle that we are working on for KCAN, it's a two-wire body bus that actually controls the instrument cluster, climate control, airbags, lighting system, and tire pressure control. So a little bit more, I have a diagram, a sample diagram over here in the middle. As you can see, like the gateway actually links up to all other different CAN bus over here, whereby you have your body CAN. Body CAN is usually used for like slower CAN bus baud rates. So for example, if you don't need that much of high speed, like your doors, opening and closing of your doors that is using body CAN. And then you have your chassis CAN over here. So the chassis CAN is more of using for like your parking, your wheel system, or your power steering in this case. Yeah. And then for powertrain CAN, you have your like airbag systems and your headlamps that are actually connected to it. And then finally for comfort CAN is usually your AC, your air conditioning or your HVAC system. Yeah. So each different vehicles for different manufacturers, they actually wire up their CAN bus differently, but this is a rough idea that you should know when it comes to CAN bus, because they're actually different speeds. So for example, like for brakes, you need a higher speed CAN bus, because you need faster response time. For body CAN, when you open the doors, you don't need that fast of a response time, so it's of a slower speed for CAN bus. Okay, so now we go to the building of the bench for bench two. So since we are a non-profit group and we actually purchase all of these components with our own budget, so what we do is that we actually choose the critical components to actually build upon. So based on the image that we have earlier from Kin Labs document, we actually purchased the central gateway module, the infotainment unit, and the telematics. So we further improvised and actually added a few more items. So you can see that there's a cluster meter and a digital diesel electronic systems over here that's usually used for fuel injection module. Yeah. So as you can see from there's three different layers here to simulate the previous architecture that we have. So layer one, we have the infotainment system, and then we have the DDE. and also the central gateway module. And due to lack of space, we have to stack them up. So layer 2, we have like the telematics module and the custom meter. And then finally on layer 3, we have like the infotainment system control. And then what you don't see is all the wirings at the bottom. And then we of course have a Raspberry Pi or any kind of like Intel NUC interface that you want to interact with the CAN bus systems. Yeah. So I will be passing on to Edmund, who will be speaking more about building challenges and getting into the infotainment system.
Thank you, Alina. So I'll be presenting on the challenges the team face while building the bench 2. So like Alina mentioned, the components we purchased, and like any other hardware, we had to connect that. And the problem with that is with vehicles, we have to match the model year and also make sure that the part numbers can work with each other, so that when we connect up the bench setup, there's no difficulties in their indication protocols. So apart from that, we also had to find out the wiring diagrams for the components, but the information is quite scarce on the internet for vehicle parts. And then as we layered up the hardware into the bench and then connected the pins to the correct input outputs, when we first powered up with the power supply, you can see that the setup is actually drawing some current, but the problem is that the cluster meter and the infotainment system is actually not powering up. So at this stage, right, we thought that maybe our wiring was wrong or there was some hardware failure somewhere. So after re-verifying our setup and also doing some research, we realized that this particular bench is actually waiting for a specific CAN message before it starts to properly power up the infotainment and the cluster. So we found out that the CAN message ID 130, as seen in the screenshot on the left, with this particular payload, when sent repeatedly, we are able to power up the bench and the cluster and the infotainment system properly boots up. So as we booted up the bench, sending the wake up signal, we realized another problem is that there was no other messages present in the OBD2 port for the CAN high control. So this tells us that actually the CAN bus is actually being filtered away from the output of the OBD2. So at this stage, we had to go back into the wiring diagrams and perform a man in the middle to read or inject CAN message directly into the CAN bus itself. So after locating the right points, and at the same time, still I'm sending the quick up CAN signals into the CAN bus, we were able to read CAN messages as shown in the rightmost screenshot. And these CAN messages actually come from the cluster meter and also the infotainment system. From this setup, we found out that actually the central gateway module is acting some sort like a firewall that filters out messages. If we are sending messages from OBD2, or we are trying to read messages from OBD2, and they only accept the CAN wake up signal. So with the man in the middle injecting messages into the CAN bus, we're able to activate some very nice functionalities in the cluster. For example, the animal collision detection shown in the left screenshot, and also the human collision detection shown in the right screenshot, along with some other telltales and also flashing light. So after spoofing the CAN messages in on the bench setup, we had to bring these messages that we found into the actual vehicle system. So in the two videos, you can see that This is actually in the vehicle, where the cluster we have cut it out, and we are connected to the CAN bus with my laptop, and we were able to spoof the speedometer display, and also on the right video, we were able to make it like Christmas event. So those messages that we have injected into the actual vehicle system is the exact message that we found on the test bench, which is safer than if you were to spoof on a real vehicle. So that's for the cluster meter. So getting into the infotainment system, with the document provided by KinLabs, it was mentioned vaguely that the infotainment system can be assigned an IP address. However, it was not explicitly mentioned how this was done. So we did some experimenting. We tried to get into the infotainment system through the USB port, the OBD2 port. But then we found out that actually we needed to set up an internal DHCP server and provide an IP address to the infotainment system. So on the left screenshot, you can see from our DHCP interface, the IP address 192.168.0.51 actually is reading the MAC address of the infotainment system screenshotted on the right. So after we have this set up, we can then scan the infotainment system using NMAC. So while we scan the IP address of the infotainment system, we found some interesting ports open in the infotainment system. So we have port 80, port 6801, port 6811. And port 6801 and 6811 are actually used for OBD2 to Ethernet access by the central gateway module. And for the HTTP port, you can see on the right screenshot, we were able to access and look at some directories in the port. So at this moment, we are still looking into what else we can find out from the open ports and also enumerate further. So far, we are doing the research in the CAN bus, and most of the things we can activate with CAN bus. So now the additional protocols that we added will be the MOST protocol. And we observe that the MOST protocol actually allows some sensor signals to be transmitted to the cluster meter. So on the left screenshot, you can see that without connecting the MOST cable, there was not much telltales showing in the cluster. So on the right screenshot, with the MOST cable, you can see a lot more warning telltales showing and a display at the bottom. So this shows us that actually the cluster meter is waiting for both the CAN message and also the MOST cable messages to determine whether some ECUs are present. So because we did not purchase most of the ECUs, it is actually throwing some exceptions, and all these are the warning telltales that showed up. Next, I'll pass on to Pei to talk about features versus vulnerabilities.
Right, thank you, Edmund. So on the topic of features versus vulnerabilities, so through our entire research, as we were doing our background research, reading through KinLabs, and going through all the different articles that were released by the news and media outlets, we realized that when we were attacking smart devices, or in a sense also like including IoT devices, smart cities infrastructures, there are a lot of built-in features and functionalities that came with it, and these features, they are meant to aid users. And however, the very same set of features can also sabotage users and also become exceptionally dangerous when combined with a remote attack. So for a case in point would be the Honda Jeep attack. So the researchers were able to remotely control the Jeep itself, and they were able to take control of the vehicle remotely, even though there was a driver in there. And that in itself is really, really dangerous. So it could happen to us at any point in time, right? So there was that, and that's more or less like why we want to do more research into such an area. We find that it is really, really important. And yeah, it's a really interesting subject topic. So summary of our learnings. For bench 2, so as Edmund mentioned previously, it's not predominantly stated that a CAN wake-up signal is required for the infotainment system. We actually went through a lot just to get this information. We went through a lot of forums, a lot of BMW forums, the KeyNet's research paper itself also, but it took us quite a bit of probing and experimenting around before we actually found out that we needed that specific payload before we were able to access anything or even cause it to wake up. So for like a couple of weeks, we were actually stuck on that, and we didn't really know why. We were pretty much on the verge of even getting new hardware because we thought that the hardware we got was broken. So yeah, that really proved to be a challenge for us. Yeah. And secondly, the central gateway module filtering out CAN messages and preventing connectivity to the infotainment system was also another issue for us. We were trying so hard to find out and assign that particular IP address to the central gateway module, and it was constantly being rejected. We couldn't find the address itself. As you can see in the left screenshot, we get to see that the HTTP port is open, ECNet is open, and another unknown port is open. But trying to get there, we even had to buy specific Ethernet adapter just for it. It wouldn't respond or interact. It wouldn't enable us to interact with it if we just use like any other adapter because it's looking for a certain chipset. So that was pretty painful. So we cycled through quite a few adapters, and now we've got a whole host of adapters with us. Just because we kept testing out and keep trying out. In the paper itself by Keen Labs, it was actually stated that there was a specific manufacturer that was required, but we didn't know exactly which one it was because it was redacted. So we had that challenge too. So in summary, the MOST protocol allows some sensor signals to be transmitted to the cluster meter, as Edmund showed just now. We didn't manage to see all of the full functionality of the cluster meter until we actually connected the MOST protocol. So we thought that we saw LED, right? We saw blinky lights on the cluster meter itself, but why weren't they working? And that was when we kind of like went to dig through the papers itself and like, oh right, we needed the cable itself. And yeah, that worked out in our favor in the end. And yeah, the CAN wake up signal along with the central gateway module filtering out CAN messages and preventing connectivity. Those two were also pretty painful for us because we went through a lot just to get there. And yeah, a lot of the information wasn't available on the internet. We went through a lot of trial and we went through a lot of like trial runs just to get that. So yeah. Going on from here, right, so bench 2 was in a sense like a stepping stone for us to move on to further benches and eventually, hopefully, autonomous vehicles. So the benches are always there to help us to understand better as to what connected vehicles are able to do. And it really gives us a feel of how actual car manufacturers build their architecture, and it enables us to understand how we're able to test out their security systems. So we have been trying to run a couple of tests and research into remote attacks, training the different types of attacks together, along with testing out the different attack vectors that's available for us, such as the key fob, infotainment, ECU testing, and hopefully side channel attacks too. So that's really the hope for us, and it's something that we really, really would like to do. And we're working on that now also. So yeah. And here's actually bench tree. So we're currently working on this right now. Stay tuned to find out more when we do actually get more information and research on that. And we'll definitely be back with another presentation on this. So yeah. Thank you. Any questions for us?